Artificial intelligence is no longer a futuristic fantasy, it's here, and it's changing the way we live, work, and travel. Imagine a world where cars drive themselves, where human error no longer leads to tragic accidents, and where transportation is smoother, safer, and more efficient than ever before. This isn't just a dream, it's happening right now. The future of self-driving cars is unfolding before our eyes, powered by AI, and it's set to transform the way we think about mobility forever. But how close are we to a world where autonomous vehicles dominate the roads? What challenges still stand in the way? And what will the future look like when AI takes the wheel? Let's dive deep into the fascinating world of AI-driven self-driving technology and explore where it's headed in the years to come. The evolution of self-driving cars. The idea of self-driving cars has been around for decades. Early experiments in autonomous vehicles date back to the 1920s and 1932, with rudimentary attempts at remote-controlled and guided vehicles. But the real breakthrough came in the 1980s when research groups and universities started experimenting with computer vision and machine learning to enable cars to see the road. Fast forward to today, and self-driving technology has made enormous leaps. Companies like Tesla, Waymo, and Cruise have successfully deployed semi-autonomous and fully autonomous vehicles in select cities. AI now plays a central role in the entire driving experience, from navigation to obstacle detection, decision-making, and even predicting human behavior on the road. How AI powers self-driving cars. Self-driving cars rely on a combination of sensors, cameras, radar, and LiDAR to perceive their surroundings, but at the heart of everything is AI. Without it, all that sensory data would be meaningless. AI acts as the brain of the vehicle, making split-second decisions based on vast amounts of real-time information. Computer vision. AI-powered computer vision allows a self-driving car to see the world around it. Cameras and sensors detect road signs, lane markings, pedestrians, cyclists, and other vehicles. This data is then processed by deep learning algorithms that recognize objects, classify them, and predict their movements. Sensor fusion. A self-driving car doesn't just rely on one type of sensor. It combines data from multiple sources: LiDAR, radar, ultrasonic sensors, and cameras to create a highly accurate three-dimensional model of its environment. AI is responsible for integrating all this information and filtering out noise or errors, path planning, and decision-making. AI-powered self-driving cars must not only understand their surroundings but also decide how to navigate them safely. Advanced neural networks analyze road conditions, traffic patterns, and unpredictable elements, such as pedestrians crossing unexpectedly or a car suddenly braking. The current state of autonomous vehicles right now, we have different levels of automation in self-driving cars, categorized by the SAE Society of Automotive Engineers. Level 0, no automation. The driver is in full control. Level 1, driver assistance. Some features, like adaptive cruise control, help the driver. Level 2, partial automation. The car can steer, accelerate, and brake, but the driver must remain engaged. Level 3, conditional automation. The vehicle can drive itself in specific conditions, but a human driver must be ready to take over. Level 4, high automation. The car can handle most driving tasks but may require human intervention in some situations. Level 5, full automation. No human driver needed, the car does everything. Currently, we're hovering between Level 2 and Level 4. Companies like Tesla, Waymo, and GM's Cruise are pushing toward higher levels, but full autonomy is still a work in progress. Challenges and roadblocks. Despite all the progress, fully autonomous vehicles still face major hurdles. Safety and reliability. AI is powerful, but it's not perfect. Self-driving cars still struggle with unpredictable human behavior, bad weather conditions, and complex road environments. Ensuring absolute safety before mass adoption remains a huge challenge. Ethical dilemmas. What should a self-driving car do in a no-win scenario? For example, if it must choose between hitting a pedestrian or swerving into another vehicle, how does it decide? AI-driven ethics is a controversial and ongoing debate. Regulations and legal issues. Governments and policymakers are still figuring out how to regulate autonomous vehicles. Who is responsible if an AI-powered car crashes? The driver? The manufacturer? Legal frameworks need to catch up with the technology. Public acceptance. Many people are still skeptical about AI-driven cars. Trust is a big issue, and consumers need assurance that these vehicles are safe before they fully embrace them. Infrastructure and connectivity. For self-driving cars to function at their best, cities may need upgraded infrastructure, such as smart traffic lights, dedicated lanes, and 5G connectivity to enable vehicle-to-vehicle communication. What lies ahead? The journey toward fully autonomous vehicles is far from over, but one thing is certain: AI will continue to push the boundaries of what's possible. As AI algorithms become smarter, hardware becomes more advanced, and regulations evolve, self-driving cars will move from being experimental technology to a mainstream reality. But what does this mean for us? Will AI-driven cars make human drivers obsolete? Will they eliminate traffic accidents altogether? Or will they create new challenges we haven't yet imagined? One day, we may look back and wonder how we ever doubted the rise of autonomous vehicles. Until then, we'll keep watching, learning, and adapting as AI takes the driver's seat, paving the way for a smarter, safer, and more connected world.